All right, for the second part of this video, we're going to look at applying CNNs to this Kaggle digit recognition challenge. The Kaggle digit recognition challenge, as you may recall, is kind of the most famous image recognition challenges out there. It's just the digits 0 through 9 written out from zip codes and trying to be recognized in different ways. So a lot of different people, different examples of the digits 0 through 9 for this. So again, you can join this challenge and compete, although that's optional for this. So in the textbook, we're going to look at CNN architectures here and how they are looked at. So we'll generally set up a number of layers and connect them together. We use an activation layer called ReLUs or linear units, rectified linear units for this. Again, but that's not too important, but they talk about this. So we'll start with an input, which is an image. It'll have often color, although in this first one we won't do color. Later on we'll do color ones. We'll have a number of different layers. We'll do some convolutions. We'll do some max pooling, which will shrink the image size. We'll do some more convolutions. We'll do max pooling that will shrink the image size, and then we'll do a fold connected layer or two, and then we'll have an output here. And so this talks about some layers, some ways of setting up, and then a simple network here for setting up this. So this sets up a layer that are stacked on top of each other in a sequential order. That's what this is called, a sequential model. So this is a convolutional 2D network, a max pooling layer, another convolutional 2D networks, in fact, two of them, and max pooling layers. And this number, well, we'll talk about this. We can talk about the size of the filter and how many filters are applied. I'm going to switch back to here. So in our CNN, in our Kaggle challenge, we are going to load in our images and set those up. We set up the data here. We split the data in some training and testing stuff for this. So again, there's lots of images here. We'll have 37,000 images. Each image is 28 by 28 pixels for this. And we'll have 4,200 images set up for testing as we go. And now we're going to talk about our layers. So first thing we talk about is a convolutional layer. That's what this was showing here, is this kind of layer. Now the textbook shows it this way: convolutional 2D, the number of filters, the kernel size, the stride, the padding, and activation. We'll tend to simplify it in this sort of technique where we'll say convolutional 2D, the first number is the number of layers. So 16 layers as opposed to 32 layers here. The next is the size of the kernel, and again we'll just say 3 by 3 kernel rather than a kernel size of 3. And the activation again will be rectified linear units. We generally always use these in these convolutional neural networks here. So again, you might see it done this way or this way. They both do the same thing. Similarly, when we get to the max pooling layers, the textbook will do max pooling this way. We'll tend to do it with this one. We'll just say max pooling, and the pool size will be 2 by 2 for this for us. We'll do a flattening layer and then a dense layer. A flattening layer will convert our 2 by 2 image into just a linear array of linear units, or a linear array of units. And then we will treat that just like inside a normal network where we can do some dense layers after this. So here's one possible configuration similar to what the book shows here. This is how we'll often see it. We'll do a sequential network. We'll do a convolutional 2D network. We'll have 8 filters. The kernel size will be 3 by 3, and the activation will be here. And for the first layer, we have to specify the input that is into this. We don't have to do that for subsequent layers. And then we do another convolutional 2D layer with 8 filters, and again, they're 3 by 3 here. Now we're doing a max pooling layer, and we're going to do another convolutional layer. Now we're doing 16 filters, and again, they're still 3 by 3. We often will use 3 by 3 filters. We'll then flatten out the network, and then we'll do a dense layer with 32 nodes, and then we'll do our output layer. We usually will specify our output layer. In this case, our output will be 10 because there are 10 digits we want to recognize. So it'll activate one of 10 nodes here. And then in the output layer, the activation has to be softmax, where everything else it is this rectified linear units. So here's kind of a picture we start of how this will look. We start with a 28 by 28 image, and we apply 8 filters. So we get now a 28 by 28 with 8 different versions, 8 different copies of that 28 by 28 image. With different filters. So we might be detecting vertical lines in one, horizontal lines with others, other things here. So we have a bunch of copies of that. Now we're applying again. Here we're applying another 8 filters with convolutions, and we're getting a new, but we're still at 28 by 28 image. Then we're applying this max pooling layer here, and then so our image shrinks from 28 by 28 to 14 by 14. Oops, I didn't want to double click on that. So, okay, let me get back and show you that image again there. So our image just shrunk, and then we'll apply another convolutional layer, but now we're doing 16 layers, but we're still at a 14 by 14 image, but now we'll have 16 different representations or views of that image. And the idea is that we will be shrinking this image down as we detect more complicated features. So here we might be detecting just lines, maybe vertical or horizontal lines. Maybe here we're detecting more shapes like squares or circles or triangles or stuff like that, or I don't know, different things here. But now maybe here we're detecting more like faces or things like this. And if we're detecting more complicated features here, we don't need, there's not as many of these complicated features in our image, so we can shrink the image down to less here. Now we do this, we end up flattening our image here and applying a dense layer of 32 nodes, and then the output of 10 nodes here. So here you can test out this. Here's our network we're going to run. And again, one thing you can watch is when you create this network, watch the network summary. It'll say, oh, you've got a 28 by 28 network after your first layer, 28 pixels by 28 pixels, and you've got 8 layers of that. And then you do another convolution, and you're sort of at 28 by 28 by 8. Now we do a max pooling, so we shrink the image down to 14 by 14 by 8. We then apply more filters. We're 14 by 14 by 16. We eventually down to 7 by 7 by 16 here. And we do some more convolutions, we do a flattening, and then we do a dense layer here. So overall, we can also watch the total number of parameters. In this example, there's 68,000 parameters or weights, network weights we're changing, which is quite a few, but we'll be soon getting in networks that are much larger than that here. So this is some stuff we're setting up for reducing the learning rate, stopping early if the learning isn't improving, and saving the network or the model at different spots. We'll talk about these later on when we get back to our textbook in some of the early chapters. So these are just set up, and you can just leave these be. Now we're going to train the network. So we're going to specify our training data. This neural network fit will train our model. Our model is NN. We define the NN model, whereas that's what we called our model, appears NN for that. So we're going to say NN.fit. Specify the training data, input and output, and then the testing data here and how many epochs we're going to run. Right now I'm just going to do 10 epochs. It could probably run for more, but I don't want it to run too long. So it'll run here, and you can watch the accuracy of the model, both the training accuracy and the validation or testing accuracy. And then we can also plot that out here. We'll see the loss should be going down, and the model accuracy should be going up here, getting close to 100% recognition with these digits. So your job is to then make some changes to this network for task 3. Maybe change the number of layers, add a new layer here. So you'd go back up here. So I'm scrolling up, up to this where I'm defining my network here. I would, maybe I would want to try more layers. The book for example, they use 64 layers and then they double it to 128. So maybe I want to do that. Maybe I want to do the exact same thing here. I want to do this at 16 layers, or maybe I'd want to do 32 layers here and 32 layers here, or 23. And then maybe double that up to 64. Generally, as we shrink the network down, we want to have more features. We want to recognize more complex features, but there'll be fewer of those complex features recognized on our image as we go through these max pooling. So often, if we start with a filter size, a number of filters here, we'll double that after we do a max pooling layer. So again, you can try different sizes here, and then when you run this, it should show the corresponding sizes here. One thing you do want to watch is you don't want to get your network down to too small of a size here. So here at our final level, we are 7 pixels by 7 pixels. So if I scroll up here, here we're at 14 by 14. I put another max pooling layer here, and I was down to 7 by 7 before we did this. For this. So you can try different things. We could actually remove a set of max pooling layers here. We could just take those out. I could cut them out, or I can just comment them out here. So here I've commented them out. And I can look at my image. So now I'm getting down to a, I have a 28 by 28 image. I go down to a 14 by 14 image, and then I do my max pooling. Now I end up with a lot more parameters. I have 400,000 parameters here. So you can try that out if you want. You can try out, let's go back here. I'm going to just add another whole layer here of another whole max pooling layer and a couple convolutional layers after that. Okay, so now I've added another whole. I've got this layer, max pooling and convolutional layers. I've done that again here. So let's see what my network looks like. So I start off with a 28 by 28 image. I shift down to a 14 by 14 image. Excuse me. Okay. 14 by 14 image, that is shifted down to a 7 by 7 image, and that's shifted down to a 3 by 3 image. So I'm guessing that this is not going to work very well because I'm not in the end detecting many features or a big size of this. It'll be interesting. Again, you could certainly try this and see if this 3 by 3 image works. So again, that's one of the things you want to try. So once you set that up, you want to go and rerun your training things and see what your results are, report that. So that's what you want to do for this part 3. So researchers have been doing a lot of work on neural networks and in different layers. So the last thing we're going to look at is, a larger data set and a different kind of network. But again, one thing you are encouraged to do is, if you want, you can actually submit your results on a Kaggle challenge. So your results you can run this code. It'll save your results in a CSV file, which will be over here. I have to click on my little folder icon on the left-hand side. Once I run this, and I can download that image. I mean, not an image, that result file, and then upload that for Kaggle and see how that goes. So if you run this correctly, I haven't run this all, but you'll see your submission file show up here, and then again you can click on it and download it, and then log into Kaggle and upload the data. Then the next thing we're going to do is look at this next section. I'll have a separate video for that.